Okay, this one is just like the task we did in class of the Mathematics Vision Project Task 2.3. So let's take a peek at this one, number 3, called Connie is making a square quilt for her grandson. Draw the diagram of the quilt given the information below, and then write 2 equivalent equations. So just like in class today, we're going to be writing the factored form and the standard form for each. So here we go. Get your drawing skills ready. A block with the side length increased by 4 units. Start with a typical X by X quilt block, and then increased by 4 units on each side. You're going to go out 4 on this side and out 4 on this side. Because a square has equal side lengths. Then those 2 outside numbers, x plus 4, become our first factored form expression. Now we multiply those to get the inside so we can get standard form. X times x is x squared. 1, 2, 3, 4 x's. 1, 2, 3, 4 x's here. There's our 16 constant. So using all of those, x squared plus 1, 2, 3, 4, 5, 6, 7, 8. So 8x plus 16 is my standard form. This shows up right here. 1, 2, 3, 4, 5, 6, 7, 8 shows up here as 8x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 shows up there. Then this x plus 4 factor shows up here in our factored form. Pause the video, try the next one. All right, let's draw it. Here's an x by x square increased by 1.5 units. 1.5 units. So this right here is 1.5 x's. This one right here is 1.5 x's. And then this corner here is 1.5 times 1.5. Yeah, grab your calculator for that one. Okay, how'd you do? Did you get 2.25 there for that constant? So the factored form is going to be x plus 1.5 squared. That comes from right here on the outside, just like before. And then my x squared plus, what's 1.5 plus 1.5? That's 3 x's plus 2.25. There's my standard form. This guy right here, 1.5 plus 1.5. I don't know how I just did that. X squared plus 3x. And then 2.25 is my corner. All right, pause it, try the next one. Let's see how you did. All right, now this one says decreased by 2 units. So technically what's happening, I draw my, oh, that looks more like a rectangle. Sorry, guys. Okay, technically I take my square, and to decrease it by 2 means I'm going to cut in by 2 on this side. So x minus 2. Then to decrease this side by 2 means I'm going to cut in on this side. But look at how the overall picture at the end pretty much looks the same as the other one, so it's not even like I would be able to tell. X times x is x squared. This one over here is going to be negative 1x and negative 1x for a total of negative 2x's. And then these guys down here are still positive 4 because negative times negative is still positive 4. So my standard form for this one, check this out. Do you see where this negative 4x comes from? Interesting, right? So 1, 2, 3, 4 negative x's, and then 4 constants. And then my factored form is just x minus 2 times x minus 2, or x minus 2 squared. All right, how'd you do there? I hope you had those nice colors. All right, for this next section, draw and identify the axis of symmetry given the sketch of a parabola. It just wants you to find the axis of symmetry, which is like right down here. So given this information, all I have to go on is my two x values of these two intercepts. Well, guess what the relationship is of this line? It's right in the middle. Your line of symmetry is going to go right down the middle. So how do I find the middle of those two x's? It's called the midpoint formula. So I want to just take this -3 and this 17, and I'm going to add those and then divide by 2. Well, -3 plus 17, that's 14. 14 divided by 2 is just 7. So let's go see if that kind of makes sense to us. -3 means 3, 2, 1, 0. And then 1, 2, 3, 4, 5, 6, 7. And that would be 3 here and 7 here makes 10. And so if this is through 7, does it make sense that from 7 to 17 is another 10? Oh, it is another 10. So my line of symmetry, identify the axis of symmetry, after I drew that in, is going to be through the middle, x equals 7. So again, this is like the little midpoint formula here for the x that I just used. So the actual formula goes like this: x1 plus x2 divided by 2. Have you seen that before? It's supposed to be a review, but you know how these things have been going. Okay, middle of this one, pause the video, try to get the midpoint. Pause the video, try to get the midpoint for this one. Okay, let's see how you did. -128 plus -15 divided by 2. I'm grabbing my calculator. I hope you did. And I'm getting -143 divided by 2. And that's going to be x equals -71.5. Ew, that's yucky. Next one is 1.72 and 6.8 divided by 2. That's 8.52 divided by 2. That's 4.26. How'd you do? So that's just finding the middle of those two. It's called the midpoint, the x. All right, good old tables. Remember these? Notice that this one is technically going up 1 on a number line. When we're adding 1 consistently on this side, we now want to look to the left and see what we're adding over here. Over here, this is going from -2. This is going up 3, up 3, up 3. Oh, this one is very, very sneaky. It is a linear, but my rate of change is not just plus 1s. It's plus 1 over 3. We have to be careful. So the function is linear because it is adding a constant rate of 1/3 each time. So my recursive goes f of -2 equals -4. F of x equals f of x minus 1 plus 1/3. And the explicit begins with -4, adding 1/3 repeatedly to the x minus -2. That should be positive. All right, that's my linear. Now I'm looking for my exponential and my quadratic. So this next one looks like really big numbers. That's always my hint that it's probably the exponential, but let's try it. I'm going to take 28,800 in my calculator right now, and I'm going to divide that by 34,560. Okay. Divided by 1.2 is the fraction that's coming out. I mean, the decimal that's coming out. But I want to know if you can figure that out as a fraction. Do you know how 0.2, do you know what that comes out to? 0.2 is 2/10 or 1/5. So if this is dividing by a 1.2, it's 1 1/5 or 6/5. Let's go check this out. So 28,800 and 34,560. I'm going to go times 5/6. Let's see if that works. 34,560 times 5 divided by 6, and it gives me this. Now I'm going to take this and do times 5 divided by 6, and I get this one. I found my fraction. So you can use the divided by 1.2, you can use the times 0.883, you can do the times 5/6, but the point is this is exponential. The function is exponential. Because it has a common ratio of 5/6. Okay, recursive. F of 10 equals 34,560. F of x equals f of x minus 1 times 5/6. Explicit, f of x begins at 34,560 times 5/6 times 0.83 times, I don't know. We'll talk tomorrow about what did you do there. And then x minus 10 is my power. Did you remember to use this number right here? Why is it little x minus 10? Because this is an exponential. It's got repeating power. Okay, last one must be our quadratic then, by process of elimination. So let's see here. I'm going down 15. 41 minus 16. I'm going to grab my calculator to be sure. I'm going down 25. I'm going down 35. Notice that that means that this has a constant second difference. Oh, is that also negative? Of down 10. So this is my first difference column. This is my second difference column. Because I have a constant second difference, I know this is quadratic. The function is quadratic. Because it has a linear first difference and a constant second difference of negative 10. All right, recursive. F of 1 equals negative 1. F of x equals f of x minus 1. Who remembers how to get that? Explicit. So we need a 0 term. We've got a 1 here. So to go back 1, let's kind of fill in the rest of this table. This right here needs a difference. So this would be negative 5 right here. And then going another 5. Let's check that out. So that would be going down 10. That would be going down 10. All right. So 0, 5 is my 0 term. So for my explicit, I know there's an x squared. I know there's a plus 5. In front of the x squared, I take half of the constant second difference. So that gives me negative 5 right here. Now I test it to see if there is a b value. So I'm going to use this input and output. F of 1 equals negative 5 times 1 squared plus 5. So negative 5 times 1 is negative 5 plus 5 is 0. Ooh, it does have a B value. Let's test the 2 just to see if it's what I'm thinking. F of 2 equals negative 5 times 2 squared. 2 squared is 4, 4, negative 20, negative 20, negative 15. I still need one more x. So minus 1x is my B value. If any of you got that on your own, wow, wowzers. That was a tough one. Okay, back to the recursive piece. This guy right here. Do you remember how to get it? Pick a row, any row. I don't care. Any of these rows. Begins with negative 15. Let's see, which color do I want to use? I'll use black. Begins with negative, no, not that. Begins with negative 15. I'm going right here, guys, right here. Minusing 10 to the x minus 2. So I said begins with negative 15, subtracting 10, x minus 2. Simplify this. Negative 10x plus 20 becomes negative 10x. 20 minus 15 is plus 5. Let me go double check my work. Begins with negative 15, minusing 10, x minus 2, negative 10x plus 20, 20 minus 15 is 5. Looks great. Okay, don't want to forget about those tables. That was first chapter. That's coming up. How'd you do on this? New stuff, brand new stuff, maybe a review, and then old stuff.